The fuel consumption of a car in liters per 100 kilometers is related to the velocity v in kilometers per hour by the formula F equals 16 minus 0.2 v plus v squared over 250. Calculate the rate of fuel consumption when the velocity is 10, 20, and 30. So what we have to do over here is we want to find the rate of fuel consumption with respect to velocity, derive F with respect to v, then substitute into v 10, 20, and 30, getting the rate of fuel consumption for each. So our first step over here is to find df dv, and that'll equal 16 derived as 0. When you derive negative 0.2v, you'll get negative 0.2 plus the 2 goes to the front, multiply it and divide it into 250 will become 125. So you'll end up with v over 125. And then for each of these, you want to simply substitute 10 in there for v. So for I, the answer will become df dv is equal to negative 0.2 plus 10 over 125. df dv is equal to negative 0.2 plus 20 over 125. df dv is equal to, if you can see it over here, 0.2 negative 0.2 plus 30 over 125. And we simply have to put this in the calculator and calculate each one. Alright, so the first part will give me negative 0.12, negative 0.12. The next one, negative 0.04. And the last one, positive 0.04. Remember, we are calculating the rate of fuel consumption, which is given by liters per 100 kilometers. As you can see, liters per 100 kilometers. So this is what we want as our final answer. So we put L slash 100 km, L slash 100 km, L slash 100 km. The next question says use calculus to find the speed at which the fuel consumption is a minimum. So once we find a derivative, all we got to do is make it equal to 0. We've already found it, so we just got to make it equal to 0. So we make it equal to 0, and so basically negative 0. So we've got that negative 0.2 plus v over 125 must be equal to 0. We're solving to find the velocity, which is the speed. Okay, so v over 125 equals 0.2. v equals 125 times by 0.2, and that gives me 25 kilometers per hour because it's speed. All right, what is the minimum fuel consumption? Is the next question. For this question over here, you know that at a minimum, all right, now you must be wondering, why is this a minimum? All right, just remember that the original function over here is a quadratic, which means it looks like that because the a value here is positive. So there will only be a minimum in this question. If this a value was negative, it would be a sad shape and there would only be a maximum. So no matter what you do, when you derive it, you'll get a minimum or a maximum no matter what, because that's where the derivative is 0. Now it says what is the minimum fuel consumption. We know what the speed is when it's a minimum, and we also know the fuel consumption formula, which is 16 minus 0.2 v plus v squared over 250. And all we have to do now is substitute that 25 into there for v to get the fuel consumption. We put that in a calculator, and that's our answer in liters per 100 kilometers, which comes to 18.45. Comes to 18.45.